Everyone. Today we are going to discuss Unit 3. In Unit 3 we are having two portions. One is drawing process and another half will be the extrusion process. Extrusion process as already we have discussed Unit 1 and Unit 2. In Unit 1 we are having introduction to the stress strain and also the second portion will be the variables related to the metal forming process. In Unit 2 we are having rolling and forging process. Unit 3 drawing and extrusion process. Unit 4 it will be sheet metal working and powder metallurgy process. Now if you see in this class, unit 3 we are discussing the first portion. The first half of the unit will be the drawing process, the second half of will be the extrusion process. So today onwards we are going to discuss the first half of the drawing process. If you see the contents in the drawing process, in today's class we are going to discuss three topics: what is rod drawing, what is wire drawing, and drawing dies and drawing dies. See, now if you see the diagrams, you already know the drawing process, which is example of indirect compressive stresses. So if you just recall or glance the classification of a metal forming process, we are having direct compressive stress, indirect compressive stress, shear stress, bending stress. Correct. So for examples for compressive stress will be the rolling and forging. Examples for indirect compressive stress will be the drawing and extrusion process. So there is a difference between drawing process and the extrusion process. In a drawing process, where we call it as a pulling force, whereas in extrusion process where we call it as a pushing force will be applied to reduce the thickness of the material. So now you see this one diagram where this one we called as a rod drawing process. The first diagram which is related to the rod drawing process, and this one is the external equipment which is used to pull the material through the die, and this is the example where the drawing process will be used. The main examples drawing the application of drawing process will be the wires, to produce the wires, rods and tubes. So now come to the construction part of this one. Based on the application, the raw material will be selected, and the dies will be selected based on the strength and the mechanical properties of the workpiece material, and the dies will be selected. Now the front portion will be squeezed. Remember here in operation, the end portion, so this is the end portion of the rod will be squeezed or cut to a certain length, then it will be inserted into the die. Clear. Remember, the end portion of the workpiece material will be cut or squeezed for a certain length, then it will be placed inside the two dies. This one we call as a hollow cross section. Remember, the exit tube is then clamped. Remember, the exit portion of the workpiece material, then it will be clamped to the jaws or the grips by using the external equipment. Clear. Now the first step will be the, remember, based on the application the raw material will be selected. Clear. And also the based on the material the dies will be selected. Clear. Based on the mechanical properties of the workpiece material the dies will be selected. Clear. See, now once the raw material is selected, the end portion of the workpiece material is squeezed or cut for a certain length, then it will be clamped to the jaws or the external equipment. This one we called as a external equipment. If you see here, jaws that will be gripped to the workpiece material. Clear. See, now come to the, once it is placed, now come to the operation. See, I already told that. See, if you see this arrow mark, this one we called as a tensile force. Remember, during operation, in operation, now come to the operation. In operation, so the entire drawing process comes under cold working process. Remember, cold working process, 90% of work will be done by using the cold working process. That is nothing but it will be done at the room temperature. In operation, once the external equipment is gripped at the entry portion of the workpiece material, when this equipment is moving forward direction, that only called as a pulling force will be applied. See, that only called as a tensile force. Clear? The deformation takes place by application of tensile force. This just you write down this line while listening this video. The deformation takes place by application of tensile force and also the indirect compressive stresses acting on a workpiece material. Clear? The deformation takes place due to tensile force and also the indirect compressive stresses. Clear? See, now you see the shape of the die also it is similar to the shape of the desired product. Remember the shape of the die which is similar to the shape of the desired product. The process is used for production of wires, rods and tubes. So these are the applications where the drawing process is used. Remember the wires, rods and tubes. So now come to the operation when the entry portion of the workpiece material is gripped by using the external equipment. When the pulling force is applied, now the workpiece will be moving through the dies continuously due to the indirect compressive stresses and also the tensile forces. The force will be applying on the workpiece material. Due to that forces, the reduction or deformation takes place. Remember, reduction in cross section of the workpiece takes place by using tensile force and also the indirect compressive stresses. Once the reduction in thickness takes place according to the required design based on the application, then it will be moved for the secondary operations. So this is the operation where we are going to write in exam. The first step is remember always based on the application it will be the raw material will be selected, then the entry portion will be squeezed. Remember the entry portion will be squeezed to a certain length, then it will be gripped by using the jaws and also the external equipment where you are going to see the carriage and also the chain drive. Clear? See, once it is gripped by using the external equipment, the material it will be moved in forward direction. See, that force we call it as a tensile force. The major stress which is acting in a drawing process is tensile force, where the minor stresses where we call it as a indirect stresses acting through the dies on a workpiece material to reduce the thickness of the material. So the application of drawing process is wires, rods and tubes. Remember, so if you have any queries or any doubts, you can chat in class group. Clear? So now we will go to next one. So this one, the entire portion we call it as a rod drawing process. So now you are seeing the wire drawing process where we call it as a bull block equipment. We call it as a bull block equipment or draw block equipment, which is used for the wire drawing process. So this one is the front view of the wire drawing process. So this one we call it as a rear view of the wire drawing process. Clear? See, now see it is same as the rod drawing process where it will be used to draw the wires or electrical cables. We call it as electrical cables or electrical wires. So the application of wire drawing is used to make electrical cables or the electrical wires. Clear? The operation in operation it is a continuous process where continuously the raw material will be pulled by using the bull block equipment, or we call it as a draw block. This one we call it as a bull block or draw block equipment. Remember here it is a continuous process. The initial in operation, what happens here, the wire will be cleaned by using the chemicals and the one end of the wire is cut. Remember, so this one is the wire, the entry portion of the wire here. So this one we called as a die and this one is the pulling force, where this one we called as a draw block. So in operation the entry portion of the wire is squeezed or cut to a certain length, then it will be inserted into the box containing the lubricant or the die. See, already you know that the function of the lubricant. The function of the lubricant is to reduce the wear between the die surface and also the workpiece surface. Clear? as the wire, see, once it is cutted to the certain length, then it will be inserted into the die as the entry portion, which is connected to the draw block, or we call it as a bull block equipment. Then as the wire passes through the die, the reduction in cross section of the wire takes place due to pulling force, that one we call it as a tensile force, and also the indirect compressive stresses acting through the die material. The exit wire then pulled by the bull block, and the wire gets winds up itself to the block. Remember, wire gets winds up itself to the block. If the larger diameter reductions are required, the rod is continuously drawn through several stages of the dies and blocks. See the front view of the wire drawing process, where this one is the uncoiled or unwinded wire. So this one we call it as a winded wire after the reduction of the thickness. So these are the drawing dies. Clear? Remember, see, the one important word is the entry portion of the wire is squeezed or cutted to the certain length, then it will be inserted into the die material, where at entry portion of the workpiece material along with lubricant enters into the die. Clear? Now the entry portion that will be connected to the bull block or the draw block. So in rod drawing, where the external equipment is used to pull the workpiece material, here we are having the draw block or the bull block. Clear? So the application of wire drawing is where electrical wires and the electrical cables and fencing wires will be used. Clear? See, now we'll move to the second one. So these are the applications. See, already we have discussed. This one is a cold working operation, where it will be used as electrical wires, cables, fences, and nail screws, rivets on the springs. And the advantages of wire drawing is where we can get the closer dimensions, and also the ductile materials can be drawn easily, and we can improve the mechanical properties. Operation is simple, there is no defects or minor defects will be obtained as compared to the other metal forming process, and mass production is somewhat is better as compared to the other metal forming processes. Clear? So these are applications where you have to remember, where electrical wire, cable, wire stock, or for fences. Clear? So next one is the disadvantages, where the cost mainly depends on the thickness of the material. If the thickness of the material is more, the cost also increases. If the thickness is very less, where the power required to reduce, or equipment required, or the extra equipments requirement will be very less, so that the automatically the cost will be reduced. So this the costly for low production is nothing but very small number of products will be made. Say for that processes, where this process the cost of this process will be more for the low production as compared to mass production. So where special sleeves is nothing but the external equipments are required to drive the part into the dies. It is nothing but the extra sleeves or the extra equipments are used to move the workpiece material into the die portion. So these are the disadvantages of the drawing process. Almost, if you see, if you go back, or if you have any doubts, you can ask me. So it's a simple process. So in exam they are going to ask, explain the drawing process with a neat sketch. Explain the drawing process with a neat sketch, or they are going to ask steps involved in wire drawing process with a neat sketch. The diagram for drawing process or rod drawing is same, and the for wire drawing it is different. Remember, the front view and also the rear view. So rear view is not required to draw, where you can draw the front view of the wire drawing in exam. Clear? So next topic is very important, that we call as a drawing dies or drawing variables. See, where you can see the diagram here. So see next one, sorry, see here. So this one is the portions, where this one we called as a die material, and this one is the upper die, and this one is the lower die. So this one is a naught. So the initial area or initial cross section area of the material. This one is the AF. This is the final cross sectional area of the material. So this one is a draw force F and a drawn wire or the rod after the reduction. Then this one is the half die angle. See, now come to the drawing variables or the drawing dies. So here, if you see, observe here A to B, so this portion we call it as a bell portion. See, if you observe here the naming of this drawing dies, AB is nothing but bell portion. So BC from here to here, so this one is called as a working portion. CD, so this one is land or a bearing region. DE, this one is called as a back relief angle. See, in exam they're going to ask explain drawing variables with a neat sketch. Clear? See, now if you observe here, the first one is the first part you have to write about the AB or the bell portion. Clear? So this you have to write here. So bell portion, see, this when we call it as the entrance of the die. This is the entrance of the die, we call it as a bell portion. The shape of the entrance of the die we call it as a bell portion. Bell shape is made so that the wire entering the die will draw lubricant. Clear? So there is a gap between the die surface and the work surface here. When the work entering through the die, along with the work, the lubricant also enters during the process. The bell shape causes the hydrostatic pressure to increase and promote lubricant to flow into the die. See, remember, the bell shape causes the hydrostatic pressure. It is nothing but along with the work material, it will takes the lubricant to flow into the die. See, already you know the function of the die, function of the lubricant to increase or to reduce the wear. Clear? And also the temperature and also the heat during the process. So this one we call it as a AB portion, the entrance of, so you can write AB is nothing but the bell portion. It is the entrance of the die. The shape of the portion we call it as a bell shape. The bell shape it will cause us the hydrostatic pressure, and it will takes the lubricant along with the workpiece material to promote or to reduce the wear, temperature and the heat during the drawing process. Clear? See, now come to the BC, we call it as a working portion, where very important in the drawing process, where the actual reduction takes place in this portion, B to C portion, that one we call it as a working portion. The actual plastic deformation, we call it as a actual plastic deformation takes place and reduced in cross sectional area of the work material. Clear? So this one we call as a, that's why we call as a working portion, is nothing but actual plastic deformation takes place, actual reduction in cross sectional area takes place. Clear? If you observe here, so this is the line where you can see the half die angle. Okay, so that is the angle where we call it as a alpha. There is a gap between the work surface and also die surface, we call it as a alpha, is also called as a approach angle. Clear? The alpha we call it as a approach angle. Clear? So AB is the bell shape where the lubricant and also the workpiece will be entered into the die material. Now second one will be the BC, where we call it as a working portion. Working portion where the actual reduction takes place. Clear? Now come to the third one, CD, land or bearing region. Land or bearing region, which has a small cross sectional area. See, after BC you can observe here C and D, this one called a small cross sectional area. The region produce frictional drag. Remember, see, after working portion, what will happen, there is a friction. By using that frictional force, it will be dragged out through the two dies. That one we call as a frictional drag of the wire or the rod, and does not cause any reduction in this portion. Remember, by using the frictional drag, it will be pulled out through the dies after the working portion. That region we called as a land or bearing region. In this region there is no reduction takes place. Clear? See, after CD we are having the DE, that one we called as a back relief angle, back relief angle. So in this portion where you can see there is a slight gap between the die surface and also the work surface. In this portion the slight expansion takes place of the work metal while leaving the die material. It also minimizes the abrasion. It also minimizes the abrasion wear. Remember, very important. So D is the back relief angle where the slight expansion of the work metal takes place while leaving from the die material, and also it minimizes the abrasion wear. Clear? So these are the drawing variables. AB is nothing but the bell portion, BC is the working portion, CD is the lander bearing region, D is the back relief. AB is the bell portion, is nothing but the bell shape is there, so that along with the work material the lubricant material will be entering into the die working portion where the maximum or the plastic deformation takes place or reduction in thickness takes place. CD is the land or the bearing region where there is no reduction here. By using the frictional drag it will be pulled out from the working portion. D is the back relief where the slight expansion takes place after the land or the bearing region, and it also reduces the abrasion wear. Clear? So today's class we have discussed what is rod drawing, what is wire drawing, and also the advantages, disadvantages, applications of drawing process, and the last topic is drawing variables. Clear? So next class we'll going to discuss the next two topics, and tube drawing process and drawing defects. Clear? Thank you.